Hello and welcome to Python Objects. I'm Charles Severance, and we're well on our way to getting through all this material in the Python. So this lecture is in a weird place. I even debated where to put it in the book. I don't really want to teach you how to write a lot of object-oriented programming, but we're going to start using objects, and I want to be able to use the terminology. And so as much as anything, this lecture is about terminology and understanding the words, things like methods and method signatures and variables and inheritance. And so think of this as a terminology lecture rather than a learn how to program or learn how to use this. It's not something you're going to figure out right away. And there'll come a time when you as a programmer really want to start using object-oriented programming. It's really a powerful and wonderful technique, but I think it's too early as a beginning programmer to really say, oh, let's write a bunch of objects. So just relax and enjoy and learn this material and think of it as sort of a theoretical thing rather than, a how to program thing. And so part of this is we're going to start reading data structures and data on how to use all these libraries, etc. And we're going to see the word objects, right? And then we're going to start hearing them. And I want you to be able to read the Python documentation so that you understand what's going on. And so, the word objects should make sense to you, even though you're not going to write a lot of object-oriented programming. And so page upon page upon page, database stuff, which we're going to talk about soon, is uses objects all over the place. And the beautiful soup uses objects. We've kind of been using them, and I've been waving my hands, and I use the word method without defining it. But now it's really time to define it and go to it. So I want to review from the very beginning what we think of as a program. So the classic program, my favorite little minimum program, is our little elevator floor converter, which converts from European elevator floors to United States elevator floors. And the key to this is that it's input, processing, and output. And this is a good way to model any program. And in that process, we've got variables, and we've got logic, we've got algorithms, we've got loops that we write, we've got all kinds of things. And we construct a series of steps to achieve some goal. In object-oriented, and frankly, you've been using object-oriented all along, the program has lots of objects, and we're sort of putting stuff into these objects, taking stuff out of one object and putting it into another object. And you've actually been doing this all along. As soon as you're looking at dictionaries and lists, you're doing objects. And so an object is quite a little thing. It's sort of its own little space inside of a program that contains code and data. And so we're working together. All these objects are now working together. It's a bit of self-contained code and data. And it is one way to take a very complex problem and make it easier by breaking it into separate things that can be engineered and developed separately. So you've been using string objects, or maybe you'd use beautiful soup or something. These are powerful capabilities, and if you had to look at all of them, it's just, hey, here's a thing, use this object, it'll do these things for you, and there's lots of details inside of it. Just don't look at it. Don't worry about it. And so there's boundaries, that things that you can use, things that you can look at, and things that really you don't bother looking at. You go read the documentation and use it, and away it goes. But then someone had to write that, and so they built an object. So what we're going to do is look a little bit under the covers of what it takes to build some of these objects. And so if we think of this program that originally just sort of did processing, we can think of it as having some kind of an input, right, coming into our program. And we have a string object, a dictionary object, maybe eventually some objects like a database object or an object that we eventually define. And you can think of as we're receiving data, it comes in an object, which is a string object, where we start putting the strings in dictionaries and do whatever. We pull out a list of them. And so you can think of data as moving between these objects. And like I say, even strings in the first week, first lecture, first week, first everything, we were using objects, and we've been using them all along. And so you can think of every string and every dictionary as a little program all by itself that has a bit of code and a bit of data. And so a string has the data, which includes all the characters that make up the string, but then there is a method called upper that does uppercase, or rstrip that strips off the right, a white space from the right. And so it's like they're almost little programs that have inputs and outputs themselves, and we can make lots of them. And there's lots of cooperating objects that make up an application. And one of the nice things about the object-oriented pattern is that they form boundaries, and within the boundary, if you're inside the object, you can say, look, I'm going to build you a string object or a database object or a beautiful soup object, and I'm going to build this capability and I'm going to give it to you in the form of an interface, and I'm not really going to care how you use it. And so we have this sort of visibility wall where I'm going to make an object and I'm going to let you use it, and the maker of the object doesn't necessarily have to know every single thing about the use of that object. But so just like inside the object, they don't have to worry about what you're doing with the object outside of it. When you're outside the object, you don't have to worry about what's going on inside of it. We, as the user of the object, we talk to its interface and we get things from it and give things to it and use functionality within that object, but we don't have to look inside of this. We can just say, oh, it's a nice little magical thing. We read the documentation, we read a web page, and it told us to do this, this, and this, and away you go. And so it is sort of this isolation boundary that works both for the programmer who's writing the object and the programmer who's using the object. And so it's a very nice pattern, and so you'll see how we're going to build code and we're going to group it together, and then we're going to be using it sort of as a big blob of stuff. So some definitions in this space, words that I want you to understand. When we're going to create one of these things, one of these objects, instances, that has some data in it and some code in it, we have to be able to define the shape of this object. What code will each object have in it, and what data will each object have in it? And that's called a class. The key to a class, and this little picture that I've got up here in all these slides, is a key. The class is a template. It's not the thing itself. So it's a cookie cutter. It knows a lot about how cookies are made. And if you have cookie dough and you hit the thing, then you make as many cookies as you want. And so this nice little cookie picture is a great mental model of how it works. The class is the template, and then the object are all of the cookies that are made from that template. But the template defines the shape and the nature of the class. So the code that we write is going of each of the objects. The code we write is the class code, and then later we say, oh, let's take that template and make ourselves an object or an instance. Now, as we're defining a class, we have two basic things that we put in the class. And there's a couple of different terminologies for this. One is method, which is code. It's like a function that lives inside of a class. Not a function that lives inside your program, but one that lives inside of a class. And so this is a scoping thing. A method is really just a function, but it lives inside the class. And then fields or attributes are data items that are in the class. And so they're variables that are defined in the class. You can define variables outside the class that you use in your program, and you've been doing that all along. But if you're saying, I'm going to build this capability, and it's going to have data inside of it and code inside of it, the code is the method or message, and field or attribute. And there are just two different sets of terminology. Method is what I'll probably use. If you look in some object-oriented patterns like Smalltalk or Apple, they often will call these messages. So you can either access a method inside of a class or an object, or you can send a message to the object. The same is true for field and attribute. It's just a chunk of data that's in the object that you may or may not have the right to access. So, like I said, a class is a template. It defines the characteristics of the objects that we're going to use to make it. It is the cookie cutter. So, dog is sort of the exemplar. Lassie is a particular dog, and so dog has fur, and dog barks, and dogs do all these things, and so we know something about dogs, but it doesn't mean we have a dog, right? The class is a more abstract concept that when it's time to get a dog, we know certain things about dogs. Instances, or objects, are once we say, oh, time to make a cookie from the template, time to get a dog, we know something about dogs. That's the creation of an object, and that we call them instances, instance of a class. So the class is it doesn't exist, but we say make me a new object using this class as its template. Oh, and now make me another one. And so we can have many, many objects from one class. So just like many cookies from one cookie cutter. Method is a bit of code that lives inside of an object. It's like a function, but it's scoped to within the object or within the class. Okay, so that kind of gets us started on some of the terminology, and we'll come back and we'll take a look at how we write code that's object-oriented.